what are polar coordinates? So basically, polar coordinates is a new set of coordinate system where we use r and theta coordinates instead of the Cartesian coordinate. Now remember, we will have a way to convert r theta to x and y. So what are polar coordinates? So what we get first, let's have a look at a simple diagram. So this is called the polar axis, right? Polar axis. And this is the radius. The radius, that's the radius, and it's inclined at an angle of positive theta. So if you go up anti-clockwise, it's positive theta. And if you go clockwise, that is negative theta. This is also r, okay? Are we good? Right, so this is just a simple representation of what a polar coordinate system is like. So all you need is either the main polar axis starting from 0. So that's r, right? R will have some fixed value, right? And that's the polar axis. And R will always be inclined at an angle of theta. That's it, simple. Now let's sketch some polar points. Where's the terminal arm and stuff? Right, so let's get some polar graphs or polar points here. So we want to sketch 2 and 5 pi over 4, right? So the radius is 2. Remember, every polar coordinate system is always r theta. So you're saying, okay, we first draw the polar axis, right? So the polar axis is starting from 0, right? Now, where is 5 pi by 4? 5 pi by 4 is, remember, we can convert it into degrees. So 5 times 180 divided by 4. But 5 pi by 4, remember, 4 pi by 4 is 180. So 5 pi by 4 will be, pi by 4 is what, quarter, right? So this is the same thing as saying pi plus pi by 4. So that's 45 degrees. So that'll be 225. Remember, this is the 180 line or 180 degree line or pi line. And that's 6 pi by 4, 3 pi by 2. Right? So 5 pi by 4 is this red line here, and the radius is 2. So you add 2 here, and you represent the angle, which is 5 pi by 4. Okay? So this is your graph, this part here. The 2, the angle theta, and the polar axis. Next one. Where is 3 and 3 pi? So we draw the polar axis. Right? Now, 3 pi. 2 pi is an entire revolution. Right, so 3 pi will just be right here. So you need to show the 3 pi and the radius is 3. So you need to show 3 there. Okay? And that's the center point 0. Next one. What happens when the angle is negative? Negative angle means you're going down. Down by what? Like 60 degrees, right? Because pi by 3 is 60, 120. Right, so this is my polar axis. That's negative pi by 2 if you're coming down, right? And we said this was approximately 120 degrees, right? So 120 degrees will be somewhere around here, right? So your answer is 3. The radius is 3. And the angle is negative 2 pi by 3. But remember, negative 2 pi by 3 is the same thing as saying going right around and saying that is 4 pi by 3. Okay? It's like coterminal angles. Make sense?
Yeah, makes sense, sir.
What about the next one? What happens when the radius is negative? So first we draw the angle, polar axis. 3 pi by 4 is about 145 degrees, all right? So 145 degrees will be somewhere around here, exactly halfway. So that's 2 and 3 pi by 4, right? Negative radius means it's a reflection across, okay? So negative radius means it's a reflection across. So it's not this broken line here, it's reflected across. So it's none of this part. So you still got to show the 3 pi by 4, right? And that will be negative 2. Okay. Now, there are other ways of representing this. The equivalent notation this here can also be 2, right? And you can go negative angle. Wait. The angle was represented incorrectly. 3 pi by 4 should be there. Because you're showing the reflection, okay? Be careful. That's not 3 pi by 4 where I went right around. It's there. Okay. Now, this here can also be represented as 2 and negative pi by 4. Okay. Now, if you're going to go positive angle, or you can also say this is 2 and 7 pi by 4. Okay. If I go right around and make the radius positive. Okay. Are we good?
Yeah, good, sir.
Right. Excellent. Next part is, okay, this is the same thing in degrees. You just need to sketch the polar points. All right. Now, how do we convert from Cartesian to polar? Right, so we have a simple diagram. Okay, let me take this diagram out, right, and redraw it. Okay, so from Cartesian to polar. So I have a diagram, like normal, Pythagoras first quadrant diagram, X, Y, and R. Right, so this is the radius. This is X, Y. Now there's no radius here now, right? So this point over here is X and Y. So what was given? The Cartesian point was given. Now you need to go and convert R. So how are you going to find R? You need to convert X, Y into R and theta. So you can say, okay, this is R and theta. How do I convert X, Y to R and theta? Okay, that's what you need to do. This is from Cartesian to polar. So you need to solve for R. So we can say R squared is equal to X squared plus Y squared. Okay. And then to solve for X, you're going to say X is equal to, no, cos theta is X over R. You need to eliminate, you need to put the X in terms of R and theta. So you say cos theta is equal to X over R. So X is equal to R cos theta. All right. And similarly, sine theta is equal to Y over R. So Y is equal to R sine theta. Okay. So how do we convert from, so if we have polar to Cartesian, wait. This was Cartesian, right? So now how are you going to find the angle? To find the angle theta, so we know how to find R, right? Let's bring this down here. We know how to find R. How am I going to find theta using this diagram here? To find theta, you're going to say tan theta is equal to Y over X. So you solve these two equations, you can put it in terms of R and theta. Now, the next part is from polar to Cartesian. What if the polar point was given? If the polar point, what if R and theta was given? Right, so if R and theta was given, you're converting it to Cartesian X and Y, then you're just going to use these two formulas. Does that make sense? You're going to put R and theta and you get X. You're going to put R and theta and you'll get Y. Make sense? And this is
Makes
from
sense.
Cartesian to polar. Great. Now, next part is how do I go? Remember, x can't be 0 here, okay? X cannot be equal to 0, so just a restriction. The third part is how to do calculus on polar curves. Right, we're going to draw polar curves just now. Show you how to draw it. It's quite easy. Just need to worry about r and theta. So we say so what's a polar curve? R is equal to, is a function in theta. Are we good? R is a function in theta. So we can represent this as x of theta is equal to r. Remember, r is a function in theta. X of theta is r cos theta. And y is also a function in theta. So that's also r sine theta. Okay. Now, if we want to find dy dx, if we want to find dy dx, we need to say dy d theta. We need to say dy d theta over dx d theta, because y is a function in theta and x is a function in theta. Now, let's find the derivative of y. So we're finding the derivative of this and putting it on top. You have to apply product rule because r is a function in theta, sine theta is also a function in theta. So you're going to say dr d theta, in other words, r prime sine theta, leave the sine theta as it is, plus derivative of sine theta is cos theta and leave the r. So r cos theta, okay? Divided by, find the derivative of this x. So you say dr d theta, derivative of r is dr d theta, cos theta. And derivative of cos is negative sine. So negative r sine theta. Are we good?
Yeah,
Make
good, sir.
sense?
Yeah,
Right,
makes sense.
excellent. Now, if there are conditions, if r is positive and dr d theta is also greater than 0, what does dr d theta mean? We're finding the derivative of the function here, dr d theta, right? If both of them are greater than 0, then the curve is moving away from the origin, right? And if r is positive and dr d theta is less than 0, okay, then curve is moving towards the origin. Curve is moving towards the origin, okay? And if dr d theta is equal to 0, then we're basically finding max and min. Maximum, it can either be a maximum or a minimum, okay? So when we're doing problems, we can solve these. So these are your notes. All right, so I explained what a polar coordinate is. It's a new coordinate system, and we know how to convert Cartesian to polar and polar back to Cartesian. Now, let's look at some examples. Example 1. Sketch the curve with polar equation r equals 2 cos theta, okay? Now, r equals 2 cos theta, the first thing that you need to do is sketch the graph of 2 cos theta, okay? Now, how do I go and sketch the graph of 2 cos theta? So part A. It is a basic cos graph with the amplitude 2. right? Sketch a graph. Yes, so amplitude is to the cos graph. Right, and so on. It's just basically 0 to pi. Now, that's 0, that's -2, that is 2. All the important points, that is pi by 2. That is -pi, that's pi by 2, that's -pi, that's 3 pi by 2, and that is pi there at the end. Now, there are some important points like cos of what? Cos of 60, which is pi by 3, right? 60 degrees somewhere. Cos of 60 is half, correct? But 2, so pi by 3, that's going to give me 1. So pi by 3 will give me 1, right? It should be negative pi, it should be pi here, right? That's 1. What about cos of 4 pi by 3? See, remember this symmetrical here. 4 pi by 3 will be closer here. 4 pi by 3, that's, let's use a calculator quickly. 120, what's cos of 120? 120 will be somewhere around
Root
here
3
as
over
well.
2. Root 3 over
Yeah,
2.
no, cos of 60, cos of 60.
1
120 is
over
like
2.
negative 1. Yeah, that's 1 over 2 times 2, that's -1, right?
Yes.
That's, what did I put here? Pi by 2. This is 4 pi by 3, right? This point is 4 pi by 3 and -1, 4 pi by 3. So I'm just trying to look for all the important points. Right, so basically that's what they have done here. It's better to sketch the graph, right? Now, for your polar curve, let me use the circle over here. It will make more sense. Just one thing with that. I just need up to 2 points, right? So I don't need such a big circle. So what I have done here is these are all the important points. Look here. So we have, this is pi by 2 line. This is 3 pi by 2 line, right? This is 0 or 2 pi line. And this point over here is basically pi line, right? So that's 90, 180, 270, 360. Now this is what? This is 30 degrees, 60 degrees. So that's pi by 3. No, 30 degrees, pi by 6, right? Pi by 6. That's 2 pi by 6, which is pi by 3, isn't? 2 pi by 6, 3 pi by 6, 4 pi by 6. That's 2 pi over 3, right? 2 pi over 3, that's 5 pi by 6. 7 pi by 6, 6 pi by 6, 7 pi by 6. 8 pi by 6, that is 4 pi over 3, right? 4 pi over 3. Yeah, that's 8 pi by 6, 9 pi by 6, yes. 10 by 6, that's 5 pi over 3. Pi by 6, that's 11 pi by 6. All right, so those are all the pi line. Now, let's start from 0. When the value is 0, what? When the theta value, remember, this is the equation, r equals 2 cos theta. So what I drew here is a function, r equals 2 cos theta, right? So this is r, and this is 2 cos theta function, all right? Theta on the x-axis. Now we're going to transform this onto a polar coordinate system. So when r is 0, when theta is 0, what's the value of r? 2. When theta is 0, the value of r is 2. So there's my first point. Are we good? So this is 1, and this is unit circle. This is 2, radius 2. Radius 1, radius 2. So this is 2. When theta is, yes, when theta is pi by 3, it is 1, right? When theta is pi by 3, it is 1. So 1 goes there, isn't? What happens when theta is pi by 6? What's 2 times cos of pi by 6? 2 times cos of 2 cos shift
1. It
pi.
should be 1, no?
Oh, no. Pi by 6.
Yeah,
Because cos of
answer
30
should
is
be
root 3
1.
over 2. It'll be root 3, root 3.
Oh, yeah, root 3 over 2, so
It
we
will be
need root
root 3,
3.
yeah. Yeah, it will be root 3. So root 3 is just like 1,73, somewhere around there. So you can see how the curve is going from here to there to there. And then when pi by 2, when it is pi by 2, it is back to 0. Can you see? So you're getting a curve from there to there, back to 0. And then what's happening after that? When the value is 4 pi by 3, where's 4 pi by 3 now? 2 pi by 3. How come I don't have, that's 2 pi by 3. Oh man, this is not 4 pi by 3, this is 2 pi by 3. Yeah. When the value is 2 pi by 3, then it is negative 1. 2 pi by 3 gives me negative 1, so I'm going to reflect it across. There's it here. Okay? And the next one, when the value is pi, it is negative 2. Pi gives me negative 2. So I need to reflect it back across. Okay? When the value is 3 pi by 2, it is, oh
0.
no, wait. Why did I move from there? So remember, I was at 2 pi by 3. Let's substitute 5 pi by 6. Let's see what's happening with 5 pi by 6. 2 times 5 pi by 6. I'm getting negative root 3.
Negative
So
root 3.
negative root 3 somewhere around here, right? And then when the value is pi, it is going back to 2. So it's basically circling like this. So you're starting your graph from here, coming down, down. You just need to join all the dots, okay? And it looks like it's a circle, okay? Right? So there's a graph here. I think the center is 1. So now let's check if this is actually true. So for part A, remember R is equal to 2 cos theta. Let's convert it into a Cartesian equation and check if it actually works. What were your equation? I want to convert this polar equation. This is a polar equation, right? I want to check for a Cartesian equation. Polar to Cartesian equation, you say x is equal to R cos theta, right? And y is equal to R sine theta. So I need to eliminate R and cos theta, right? So let's not eliminate R as yet. What is cos theta? Cos theta is x over r, okay? And I've got r there. If you cross multiply, you will get r squared is equal to 2x, correct? But what is r squared? R squared is equal to x squared plus y squared. So I'm going to write down x squared plus y squared, bring the 2x over, minus 2x is equal to 0. This here looks like it's an equation of a circle. So you got x squared minus 2x plus y squared is equal to, now remember I told you to put plus something squared and plus something squared, right? So you're going to say plus, you need to divide the coefficient of x by 2. You're kind of like completing the square for the equation of the circle. So minus 2 divided by 2. So that's like you're adding 1 squared here. So you need to add 1 squared here. This here will become a perfect square. So that's x minus 1 all squared plus y squared is equal to 1. So basically this is center 1, 0 and radius is square root of 1. Radius is equal to 1. So basically you'll get the same graph like this, what I just drew above. Not always you can convert a polar equation into a Cartesian equation, okay? So center is 1, 0, right? And the radius is 1. So you'll go to a maximum value of 2 there. And can you see the polar equation was exactly the same? See this equation here? It's the same thing. It's the same circle. Can you see the circle here? That's how you draw polar curves. You have to look at the curve of the polar equation, right? Draw the graph and then transform that information into a polar coordinate system. Find a Cartesian equation for this curve. So I already found you the Cartesian equation for the curve and I proved it, okay? So that was part B. Be good?
Yes, sir. Good.
All right, excellent. So now you know how to solve. Now you know how to draw polar graphs. You look at the original trig graph and then convert that information from there to there. All right. Next part. Let's look at some calculus on polar curves. Right. Example 2. Right, so we got r equals 2 plus 2 sine theta, okay? From 0 to 2 pi. Are we good? Now,
Yeah.
we need to go and sketch this. I've already sketched this because remember, you need to look at the 2 sine theta graph and shift it 2 units up. So I will get a graph like this, basically. We can check each point, right? Right, so this is r and that's theta. Now, remember what was the original function? Original function is 2 sine theta. So you're basically what we are doing is looking at this graph here, the original function r equals 2 sine theta. I'll do it again for you, like how to sketch this graph here. You know the sine graph starts from here. This is one wave of the sine graph, right? There's 2 here, and we can go further up. Now, remember all these points, important points, that's pi by 2, that's pi, that's 3 pi by 2, and that's 2 pi. Now, let me just trace this curve here for you and see if you're getting the exact same thing. So what am I doing with this curve? I'm moving it 2 units up. So now you understand how we got this curve here. See? Are we good? See, that point, this point is occurring exactly at pi by 2, and that point there. Right? So let's focus on the line of symmetry here. That's a line of symmetry, right? This is y is equal to 2. Now, I need some important points on the sine graph. What are the important points? Like 30 degrees, sine of 30 is half, isn't it? So you can see this point 3. What would this point here be? Pi by 6, right? There's another point 3 here. So if I put pi by 6, sine of pi by 6 is half. So 2 times half is 1. 1 plus 2 is 3. So there's 3. There's another, that point there will be 5 pi by 6, sine of 150. 5 pi by 6. Pi by 6, 5 pi by 6. Right? Next one is moving close to 1 now, right? At 1, what is this point here? 7 pi by 6. And this point over here will be 11 pi by 6, okay? 11 pi by 6, right? Because sine of 7 pi by 6, sine of 210 degrees is basically negative half. Negative half times 2 is negative 1 plus 2 is 1, right? And same here. So those are some 4 important points that's also vital on this graph here. Now we want to sketch this polar curve. So let's see what this polar curve looks like. Let me put the 45-degree lines as well, right? I'll put these lines in broken forms, right? I'll break up these lines. So that's a 45-degree line, okay? What about a 30-degree line? If that's a 45-degree line, that's a 45-degree line. So cut it in halves, right? So don't worry about these. This is just broken lines, helping lines, okay? You don't like how we had helping lines before? Same. So these are all my helping lines. All right, so I've got some helping lines here. You with me? Is making sense?
Yeah.
Right. So what are these helping lines? This is pi by 4, right? This is 2 pi. That's pi by 2. This is, you know what? Let's count in pi by 6s. No, no, it's fine. It's fine. This is pi by 4. That's 2 pi by 4. So this is 3 pi by 4. That's 4 pi by 4. So this is 5 pi by 4. So 6 pi by 4. So this is 7 pi by 4. Right. So I've got all this sorted. Now let's draw our 30-degree lines. Okay. I'm just estimating. All right. So 30 degrees is somewhere around there. Okay. That's my 30-degree line. So that's pi by 6. And if you go to the other side, no, a little bit more lower down, sorry. Yeah, so this is pi, so 6 pi by 6, 7 pi by 6, yeah, right? And then the other 30 will be closer to, what about 150? So this is 11 pi by, so this is 11 pi by 6. That is, yes, pi by 2. This will be 5 pi by 6, right? So remember, those were some of the important, what was it, 5 pi by 6? Yeah, 5 pi by 6, 7 pi by 6, 11 pi by 6, and 5 pi by 6. Right, so now let me break up these lines here, right? Because these are the lines that I will be using for drawing. And if we need more points, we will use more points. Right, so let's start here. When the value is 0, okay? What's happening when the value is 0? Let me draw it in like a purple color, right? So when the value is 0, theta value is 0, the radius is 2, isn't it? When theta value is 0, the radius is 2. Let me mark off 2 there, okay? So 0 and 2 is right here at that point. So I'm starting, that's my starting point. When the value is pi by 6, the radius becomes bigger, it becomes 3, isn't it? Are we good? So that's 2, that is 3. When the value is pi by 2, then the radius becomes 4. I need to move this in a little bit closer in. So I can just take the top point. So let's take 2 right there. let's take this 0.3 out. Move it 3 there, right? So that is 3. You understanding, right?
Yes, sir.
2, 3. When the value is, you can go and work out what is pi by 4 by substituting it inside here. 2 plus 2 times sine of pi by 4. So 2 plus 2 sine shift pi over 4. I'm getting 2 plus root 2, which is 3.41. So you can see the radius is increasing, right? 3.41. So I worked out this one as well. Now, when you go to pi by 2, it becomes 4. Why? Because you can see the point here. It's pi by 2, it is 4. So radius becomes 4. And I think you get the maximum point here, isn't it? Radius is maximum right at that point. Now, so far my graph looks like this. Watch. So far my graph looks like this. Okay? It's going in that direction. Now, let's go to 5 pi by 6. 5 pi by 6. Did we do 5 pi by 6? 5 pi by 6 is after. Yeah, now we're going to 3 pi by 4. If we put 3 pi by 4, I'm getting 2 plus root 2 again. So you can see the radius decrease is the same thing. It's 3,41, isn't it? Make sense?
Yep.
3,41. So I can go from here back to there. And then 5 pi by 6, I think is going to be 3. Yeah, 5 pi by 6 it is 3. So you can see the graph carries on to 3. Then it goes to at pi. The value
2.
is pi. It is 2. Good. It is 2, right? When the value is 7 pi by 6, it becomes 1. So it's kind of like curling in. It goes to 1, isn't it?
Yeah, it is.
Yeah. And then when the value is 7 pi by 6, it is 1. When the value is this value, what is this value here? 3 pi by 2, it is 0, isn't it? 3
Yeah.
pi by
Yeah,
2,
it is 0.
it gives me 0, but it should be 0 from, it should go across this and then 0. And then you can see it's kind of like symmetrical. Then from there, it should go there to 1 and then join up to 2. Okay? So it's a cardioid. Can you see? Like
Yeah, yeah.
it's a cardioid basically. So we call this curve a cardioid. I think
Uh,
I
by the
think this
way,
was
sorry. The every single the question we should solve like this. Yeah. Showing
no, 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 no,
the.
no. You shouldn't solve like that. I'll show you what to do. Because only in word problems you will be able to draw this, but there are some tricks to the problem. So see, this is a cardioid. That's the reason why I wanted to draw it for you to show you that it looks like this. Okay, are we good?
Yeah.
Now let's look at the second question. I just added this question. It wasn't in the questioning technique. I just added this question because I want to show you how to sketch polar curves. Okay. Now, next question. Now let's do calculus now, right? Because we know how to sketch the graph. The reason why you need to know how to sketch the graph is to find areas, right? So next question, uh, find the slope of the curve at the point where theta equals pi by 6. Part B. Now, what was the curve? Now, when theta equals pi by 6, where's pi by 6? Pi by 6 is here. Pi by
30
6 is
degrees.
here,
Yeah.
isn't it? Yeah, pi by 6 is right here. Uh, Now let's check. What was our formula? Remember, r was a function in theta, right? and we said x of theta was r cos theta and y of theta was r sine theta. Right. So now I don't like to remember this formula because I want to find we want to find the slope of the curve. Right. So what does the slope of the curve mean? It means you need to find dy dx. Right. So what is dy dx? Dy dx is basically, remember what it was, dr d theta times dr d theta times sine theta plus r cos theta divided by dr d theta with respect to x, right? It was cos theta minus r sine theta. Are we good? That's a formula I derived when we're doing calculus on polar curves there. Dr d theta sine theta plus r cos theta, dr d theta cos theta minus r sine theta. Are we good? Now, what is dr d theta? Dr d theta, what was r? R was 2 plus 2, 2 plus 2 sine theta.
Sine of theta, yeah.
Yeah. What is dr d theta then? Dr d theta will be 2 plus 2 cos theta, correct? We're just finding the derivative of this. Now, that's what it is. Now, you put this,
Zero plus 2 cos theta, no?
yeah. Sorry. Derivative of 2 is 0. That's correct. Just 2 cos theta. Excellent. The derivative of this is basically 2 plus cos, just 2 cos theta. Now you need to substitute this inside here. So what is dr d theta? 2 cos theta sine theta plus r. What is r? 2 plus 2 sine theta. You know what? You don't need to do all this because we are evaluating this at what? We are evaluating this at pi by what? We are evaluating this at pi by, so r of pi by 6, which is 30 degrees. That's 2 plus 2 sine pi by 6. What is sine of pi by 6? 30, which is half. So that will give me 3. And dr d theta evaluated at pi by 6 will give me 2 cos pi by 6. What is 2 cos pi by 6? Pi by 6 is root 3 over 2. Cos
Just
2
root 3.
cos 2 cos shift pi by 6. Yeah, oh man, why did I put that? Pi by 6. Yeah, I think, yeah, it is root 3. You are right. It is root 3. Okay. So that is root 3. Now you already know the answer. What is dr d theta? Because we're finding that evaluated at pi by, we evaluating this as pi by 6, right? Now we substitute. What is dr d theta? Root 3. What is sine of that? Half plus, what's r? 3. Correct? What's cos of that's root 3 over 2? Make sense? Divide, let's substitute everything and then simplify at the end, right? Dr d theta is root 3. Cos is root 3 over 2, correct? Subtract, what's r? 3. What is sine? Sine of pi by 6 is half, correct? So you got root 3 over 2 plus 3 root 3 over 2 divided by 3 over 2 minus 3 over 2. Whoa, 3 over 2 minus 3 over, so this is 0. Is it? Denominator is
Oh,
0.
so
This
error.
basically means, no error. This basically implies that
Oh,
vertical tangent. It's a
vertical
vertical
tangent, yes.
tangent at pi by 6. Now let's check if there is a vertical tangent at pi by 6. Where's pi by 6? Remember, pi by 6 is somewhere around here. And I don't think I drew this thing properly because vertical tangent would have been looking like this now. Yeah, because you see, I was just estimating, so it should have been like this, right? In other words, this thing's supposed to be going a little bit more inside, but if you put this line over here on the accurate graph, right? If you put this vertical line on the accurate graph, it's a vertical tangent at pi by 6. In other words, this point here, this line over here is pi by 6. This is pi by 6 line, and at pi by 6, we have a vertical tangent. So horizontal tangents at your horizontal tangent will occur at -1 and 1 and at 4, isn't? Makes
Yeah,
sense.
it is.
You can get
Yeah, makes sense.
horizontal tangents here. You can get horizontal tangents here. There's a horizontal tangent here, and you get horizontal. So what does this mean? It means that we found that dx d theta, if dx d theta is equal to 0, then you get a vertical tangent. Okay, makes sense?
Yeah, makes sense.
And if you get dy d theta equal to 0, then you get a horizontal tangent. If the top is 0, then you get a horizontal tangent, isn't? Because what does dy dx, the derivative with respect to x is equal to 0? It means you have a horizontal tangent. Anyways, now let's move on to the next question. Maybe the next question might work out because I got the same question, but evaluated at pi by 4 now. Now, when you're evaluating it at pi by 4, you do the same thing. I don't need to restart everything because you already have all the important points here, okay? So I'll just copy all this. The only thing here is that we are evaluating it at all that remains the same. R is f of theta, and all that remains the same. Now we're not evaluating at pi by 6, we are evaluating it at pi by 4 at 45 degrees. So R evaluated at pi by 4 is 2 plus 2 sine pi by 4. Sine of pi by 4 is root 2 over 2, isn't it? So you're just going to get 2 plus root 2. Are we good?
Yeah.
Dr d theta evaluated at pi by 4 will just be 2 cos pi by 4. That will just give me, that's root 2 over 2. 2's cancel out, right? So just root 2. Make sense?
Yeah, makes sense.
Right, so we got those two quantities. Just put everything inside here. So what is dr d theta? Dr d theta is root 2. Sine of pi by 4 is root 2 over 2. Plus r, what's r? 2 plus root 2. Cos of pi by 4 is root 2 over 2 divided by dr d theta is root 2 cos theta. What's cos theta? Cos root 2 over 2, right? Minus r. R is 2 plus root 2. Sine theta is sine pi by 4, which is root 2 over 2. I think this will be easy to simplify because all the root 2's can cancel out if you take a root 2 over 2 as a common factor, right? If I take a root 2 over 2 as a common factor, or divide the top by root 2 over 2 and divide the bottom by root 2 over 2, everything cancels out, isn't it? Divide the
Yeah.
top by root 2 over 2 and divide the bottom by root 2 over 2. So you can see all of this cancels out. So must be smart in simplification, right? So that cancel out, that cancel out, that cancel out, that cancel out. Or you can factor it out and cancel it out. So what you left with on top is root 2 plus root 2. So you left with 2 plus 2 root 2. And the bottom you left with what's root 2 times just root 2. Root 2 minus root 2 is out, isn't it? So you left with root 2 minus root 2, that's out, just minus 2. So you're simplifying this, 2 over, that's minus 1, minus root 2. That's what I've got. Are we good?
Yeah.
Yeah, so that's our answer. So minus 1 minus root 2, what does that mean? It means that if you go to pi by 4, if you go to pi by 4 lines, there's a pi by 4 line. So if you try to draw a line you can see this line is downward sloping because the slope is negative. Can you see? This is a negative slope, right? That's a negative slope. Now, what does that mean on the graph? What it means on the graph is that if I go here, what it means on the graph is, let me take this caveat again. What it means on this graph is, remember the 45-degree line? If I draw a 45-degree line here, because it's pi by 4, right? 45-degree line. You can clearly see that this line, there's a slope here. There's a slope. So what is the slope of this line? The slope of this line is dy dx is equal to negative into 1 plus root 2. I just factorize this up. And you can see this is downward sloping. Makes sense?
It
So you
makes
can
sense.
actually
Okay.
you can actually find the equation of this line also, right? How can you find the equation of this red line? Let's just do it. What is y of theta? What's y of theta? Y of theta was r sine theta, correct?
Oh
And
yeah, yeah.
what was x of theta? R cos theta. Let me put this together. Now, what's the theta value? Theta value is 45 degrees, right? And remember, theta is equal to pi by 4, right? And what was the R answer? Didn't we have an answer for R? The answer for R was 2 plus root 2. R evaluated at 2 plus root 2. Now, what's the answer for X then? That's 2 plus root 2 times, what's cos of theta? Root 2 over 2. What about here? 2 plus root 2. And what is sine of theta? Sine of 45. Sine of pi by 4, which is, why am I putting an arrow? These are equivalents. I'm evaluating at these 2 points. So I can simplify this. To simplify the second one, 2 plus root 2 over 2. 2 times root 2 over 2 is root 2, correct? 2 and 2 cancel out. Root 2 times root 2 over 2 is just 1. So both these points ends up being the same thing, root 2 plus 1. So where is this evaluated? So you got a coordinate, you have a point which is root 2 plus 1, root 2 plus 1, and your slope m is dy dx, which is negative 1, negative root 2. Does that make sense?
Yeah.
So now you can just say y minus y1 is equal to m into x minus x1. What's y? Y minus what's y1? Okay, y is equal to, take the y1 over and simplify. M is negative 1, negative root 2, or negative 1 into 1 plus root 2 is better to write it out like that, into x minus, what's x1? X1 is root 2 plus 1. Okay? Plus y1. I'm going to add y1 onto the other side. I'm finding the equation of this tangent line here. This is the tangent line to the polar curve. And this is y1 is root 2 plus 1 as well. Now you can open up everything and simplify. Negative into this is negative 1 plus root 2x. Negative times negative. It's like kind of like squaring a binomial here. It's positive 1 plus root 2 squared plus 1 plus root 2. Well, this is just your constant, all right? All this is just your constant, and this is your slope. And it's written in the form y equals mx plus b or mx plus c. Makes sense?
Yeah.
Right, so the question didn't ask for this. The question just asked for the slope. The slope is negative into 1 plus root 2. And you can see the geometrical interpretation of this. Okay? Are we good?
Yep.
Right, excellent. Next question. Uh, find an interval where the curve is getting closer to the origin. When is a curve getting closer to the origin over here? Or look on the graph. You're getting closer to 0. When it's between, see, look here. You can see the radius is dropping and getting close to 2. You're getting close to the symmetrical line. So it's from pi by 2 to 3 pi by 2. Makes sense?
Yeah.
From pi by 2 to 3 pi by 2, you can see the curve is getting closer to the origin. From pi by 2 to 3 pi by 2. There, look. See, from the maximum radius 4, it dropped, 3, 3, 2, 1, 0. You can see 4, 3, 4, 1, 3, 2, 1, then it became 0. So when is the curve getting closer to the origin? From pi by 2 to 1. And when is it getting furthest away from the origin? From 0 to pi by 2, isn't not from 0, sorry. Furthest away from the origin is going to be from 3 pi by 2 to pi by 2, the other way around. So closer to the origin is from the maximum point dropping down, coming closer to the origin. So from when theta is between pi by 2 to 3 pi by 2, it gets closer to the origin. And when theta is moving away from the origin, all right? Theta is an element, okay? And when theta
Okay.
is between, when theta is, look at the graph. It's just visual answers here. From here, what is this line here? This is pi by 2 line. From pi by 2, you can see the radius is increasing until 4. So from pi by 2 to 4 is moving away from the origin. 3 pi by 2 you can't include because that's further from the origin. Okay, right, that's one way to check if the graph is drawn. What if the graph wasn't drawn? What was the equation? Equation was if r is positive, dr d theta must be positive. Right, so let's see. What is r? R of theta is basically 2 plus 2 sine theta, right? What is dr d theta? That's 2 cos theta, right? I need to solve 2 cos theta, which is so I need to check r positive and dr d theta negative because we want closer to the origin. I'm looking for that answer. Dr d theta needs to be less than 0, right? Okay. So if you're solving this equation equal to 0, you're just going to say cos theta is less than 0. Now, when is cos theta less than 0? You can look at the cos graph. When is cos theta less than 0? There from here. So theta is an element from pi by 2 to 3 pi by 2. Okay? There, pi by 2. When is it less than 0? There's a cos graph. There's a cos theta graph. When is cos theta less than 0? I'm solving this inequality. So it's from pi by 2 to 3 pi by 2. Actually, shouldn't be a square bracket. It should be round brackets. Okay? Are we good?
Yeah, great.
All right, excellent. Now, we had more questions, yeah? Find an interval where the curve is getting closer. Find the value of theta where the point on the curve is furthest from the origin. That's easiest. furthest from the origin means it's a maximum, isn't? Maximum or the minimum. And we can see it occurs at pi by 2 exactly. The value is 4 on the graph. But what if the graph wasn't sketched? So you need to find dr d theta, right? So we know dr d theta is 2 cos theta, and you need to make it equal to 0. So if you make 2 cos theta equal to 0, you're going to get cos of theta is equal to 0. On the cos graph, when is it 0? When theta is pi by 2, or when theta is 3 pi by 2. So we need to check at 3 pi by 2 what's the value, right? At 3 pi by 2, the value is 0, but at pi by 2, the value is 4. So when is it the maximum? Max when theta is equal to pi by 2, and we're getting the radius 4. And this is minimum. Remember what dr d theta equal to 0 solves. It solves for maximizing max or minimum. So when theta is equal to 3 pi by 2, then you get a minimum. And the value of r is 0. Are you good? Are you good?
Wait,
Make sense?
again, so maximum and minimum again?
Yeah, you need to find the derivative with respect to theta. You get 2 cos theta equals 0. Cos of theta is equal to 0. When is cos of theta equal to 0? When it is pi by 2 or 3 pi by 2. Right?
Okay.
Now, how do you know that at pi by 2, the value is of r is 4? You need to double check. You need to substitute into the r function. How do you know it's the maximum or minimum? So you need to substitute the value of theta, which is pi by 2. If you substitute theta as pi by 2 into the function, r is equal to 2 plus 2 sine theta. Evaluated at that's r of theta, right? So what's r of pi by 2? Sine of 90 is 0, right? So just,
Yeah.
no, sine of 90 is 1. So 2
Oh
plus
yes, I
2,
know it is on. Yeah.
which is 4. So you can see this is the maximum. And then how you know r is 0? Because if you substitute 3 pi by 2, so you got r of theta is equal to 2 plus 2 sine theta. So r of 3 pi by 2 is 2 plus 2 times negative 1. Sine of, what is sine of 3 pi by 2? You can see is negative 1 here, right? So that will give me 0. So this is a minimum. So you understand what dr d theta solves. It solves for maximum or minimum. Make sense?
Yeah, makes sense. Okay.
Right, great. Okay, so that's what you need to know. I hope you understood everything.